Zero-point energy, or ZPE, is the idea that even in a complete vacuum, at absolute zero temperature, empty space isn't truly empty. Quantum mechanics tells us that particles at the tiniest scales are constantly flickering in and out of existence, creating a background energy that never disappears. This is known as zero-point energy, the lowest possible energy a quantum system can have, but it's not zero. Scientists believe ZPE could revolutionize energy in that it would produce limitless, clean energy. This, of course, isn't in the best interest of the powers that be, which is why many of you, like myself, haven't heard of Floyd Sweet. Also known as Sparky, was a U.S. Air Force veteran, NASA intelligence officer, and inventor, known for his work in technical soaring, glider training, and later, his controversial research into electromagnetism and gravity. The exclusive device he invented is called the Vacuum Triode Amplifier. The VTA was an experimental device that Mr. Sweet claimed could amplify electrical energy by extracting it from the vacuum of space. He proposed a theoretical model of how the device worked, suggesting that it utilized a phase-conjugated vacuum and bucking B fields. The proof of concept you're about to see is extremely rare and defines zero-point limitless energy.
The late Floyd Sparky Sweet is credited with creating a breakthrough magnetic solid-state motor. A magnetic specialist with a distinguished industrial career, Sweet was a man whose technical claims could not be easily dismissed. Many credible witnesses saw his device work, and Toby Groats was able to photograph these demonstrations.
This is Floyd Sweet's vacuum triode amplifier, powering two 100-watt incandescent lamps and a small DC motor. The term vacuum triode amplifier, or VTA, is a word that was coined by Tom Bearden in order to explain the phenomenon of how energy from the zero-point energy state was coupled into Floyd Sweet's over-unity free energy device. The hardware configured in this photograph was set up and run, producing in excess of over 2 million to 1 power gain. It's definitely one of the outstanding examples of how zero-point energy over-unity devices can be made to actually function and work.
So we have a 120 volt fan. As you can see, it's turning at good power. It is providing quite a breeze, and it's real usable power. And here, just coming into view, you see 5 100-watt lamps, ordinary garden variety household lamps, brilliantly lit. So there's 500 watts of very real power here.
Let us now review some more detailed test results on the Buga Sphere. The scientists are now reviewing its nucleus and performing experiments using a Venn diagram.
Very much. I would like to share with you the following thoughts. It's my full responsibility. It's my own theory. And I've been trying to stick by scientific facts of how this sphere operates. And when I witnessed the videos, the first question I asked myself was, where's the energy source so that it levitates? Where is that energy source? Engineer Avila didn't detect any batteries. We only saw a nucleus with 3 different densities, which I would like to share with you. Go ahead. Can we see the image on screen? This nucleus that was observed, as Engineer Avila said, we can observe that there are 3 different densities that are in evolved. Let's let the video run a bit, and we'll have the image on screen any moment. This is the nucleus, and it's real. This is an image that was made of the sphere, that was made at the university. It's a tomography. As you can see, there are certain holes right here that are located at the equator, which is right here, right through the center. We got the northern hemisphere and the southern hemisphere. When I saw this, I asked myself, once again, where's the energy source for it to levitate? Reason for which I started investigating how satellites have a cable and they can be charged through the cable. But I was reminded of Nikola Tesla. Nikola Tesla experimented with his famous tower, the Wonderclear. Let's see what he did. As you can tell, this Tesla tower, if you see it vertically, you can see that there's a tube that goes down the center, which is an electrical conductor. It goes underground, and we have certain pallets that are being generated with the current. It generates an electric current, and it's distributed up top. And when the plates move, it generates the necessary charge. Let's move forward. So then I asked myself the following. What if we grabbed the Tesla tower and we inserted it into the sphere? And since there's no river to generate those electrical charges, according to science, is only through friction. You should rub those materials together to create friction. And then I thought of this. Next image. When I generate electrical charge, we would have a field. But let's stop for a moment. Let's go back to the previous image, please. These charges are going to be distributed throughout the sphere. But there's something that is very important. There's a physical property within physics that tells you that the addition of magnetic fields that you can add to a sphere, they will counter-arrest each other. That's the Gauss law. The electrical field is equal to zero. But what if we make it rotate? So there's friction at the center. So when we start to make the sphere rotate, we start generating different fields. Let's stop the video right there. So then I thought, if I generate what Tesla did back in the day, generate static electricity up top, would it help? Would it give me more answers? It was in 1832 that Charles Darwin, he discovered spiders on his ship, on his boat. He thought that the spiders were being transported by the wind currents, but it was opposite from what Tesla knew. What really happened with those spiders going on to Darwin's ship is the following. You see how the spiders shoot up in the air. The spider fixes itself onto the trunk, which has negative charges. And then the static makes the spider rise, because there's a difference in potential. And that's why the spiders levitate as such, and they can travel for thousands of kilometers. And the only way of having them stop is by cutting their spider webs all together. But they're using the spider web as a rail and static as a fuel, which is different from other types of technology that do have a direct control on their flight. Next slide, please. Let's look at this principle with an experiment that was done at Mexico's Autonomous University with the bandograph. If you generate a current, it will generate an electric charge which will be eventually discharged at the ground level. But if you warm it up with a flame, you realize that the sphere is generating its own static when you apply heat to it. Next slide, please. Here's the smaller sphere. We're applying heat to it. Let's go back a couple, right there. A little bit forward, please. As you can tell, when you turn on the sphere, you have electrical current, and the static goes all the way up. It could be the spiders as such, or the Google sphere itself. They are being moved due to static. Now the generator is within the sphere, and it's generating the necessary fields. There's a difference in potential with the atmosphere, and they have opposite charges. Next slide. We can do a comparison of a spider flying through the air with the Buga sphere. Look at how it's behaving. Look how they're levitating in the same fashion. So we suspect that the sphere is levitating thanks to static fields that are reacting with the atmosphere. This is the reason why, if the sphere has to rotate for it to be charged up, if it touches high voltage wires, it's going to be discharged, causing disequilibrium on the inside, and it descends. Next slide. This is a turbine. I'll tell you what we are pretending to do. For a turbine to work properly, we have the Platon cycle in thermodynamics. We're talking about gases. So to achieve this, we have to put air through the turbine. The reactor comes on and the cycle starts. What we want to do, next slide please, is to help the sphere so that as the wind turbine has a starter, we can start it like a spark plug. Next one please. Well, we got a little time left. Well, tell me, please. Yeah, we got the image of the sphere that's rotating on screen. So we place the sphere in an instrument that will make it rotate at a certain speed, revolutions per minute. If we achieve that speed, we might be able to reactivate it, turn it back on again, and make it levitate once again. But there's 4 obstacles. If we levitate it, if we do it outside and they detect it, it might float away, right? If we do it within closed doors, it's not going to fly away, right? But how do you turn it off? Number 3, thank you. This is the third problem it would present. This is the animation of the device that will make it spin. And we're going to try and prove if this theory is invalid or if it's valid. And we're basing ourselves on physical concepts. And when we start to make it spin and when we create friction on the interior of the sphere, it creates electricity, it creates static, and we assume that it will levitate. When we talk about the chip, it looks like an antenna. We're trying to detect where the resonance comes from. If we manage that, then we're going to understand this perfectly, what its impedance is. And once we know what its impedance is, we'll be able to know what its ROE is. And then if we don't do it, then we're going to remain uncertain. Those are very important aspects. One is to try and make it levitate, what would happen? That would be success altogether. We proved our theory, right? And then we have to bring it back down, right? Could they take it away? Yeah, they can take it. We can't control it. We can't stop it. But if it's confined, then we could. And the other is to use the same system that you use for transmitting and receiving signals to be able to communicate with them. Yes, and point number 4, which I didn't talk about, if it's on or not, maybe it's on autopilot. If it's on autopilot, it'll never go on. And how do we know this? When we run the necessary tests. Don't worry, we'll figure a way of turning it back on. Thank you. Imagine that. Do you think it's possible? This is the reason why we need all of your support to be able to do a multidisciplinary study that is good for humanity.
This sphere becomes more intriguing the more tests that are performed with it. We've learned how spiders can fly by static electricity, and the sphere may use the same principle. I, like many of you, feel it's illogical to think that the sphere is uncontrolled by its creators. So the scientists' point on using the centrifuge to spin it, possibly restarting its levitation, may very well make it fly away, continuing on its predetermined coordinates. The testing of the device is really only in its infancy, and I look forward to continuing with you, learning all we can.